Now, here's the question we're going to look at first today. Before we actually launch into it, I just want you to think about how could you prove this? We looked before about the different ways you could prove things, right? The different ways we can mathematically prove things. I think I gave you 4 examples, didn't I? Right? And there's others. How could you go about it? If you were trying to do it directly, which is the normal way you prove things, where would you even begin? You certainly couldn't do it by exhaustion. I mean, it goes forever, right? Anyway, it's just a thought for you. Because, I mean, we often say, well, why do we have to prove it this way? It's like, well, in this case, how else would you prove it? Induction is a very elegant way to do it. What were our 4 steps? How does an induction proof stick together? With tape, right? So, what's our very first step here? Very first step. What am I going to test? Okay, so the first allowable case, which I've said for you, they might have just easily have said this, okay? In which you would have said, okay, it's positive, and 1 is the first positive number, okay? So I'm going to test n equals 1. Good. Let's give it a go. 4 to the power of 1 minus 1 is 4 minus 1, which is 3, okay? Great. If you really wanted to make it super obvious, by the way, that this is, true enough, a multiple of 3, you'd say it's 3 times 1, because it's 3 times an integer. That's what makes it a multiple. Anyway, it's evidently true, okay? It's true for our first allowable value. Now, one of the reasons why I'm introducing this kind of problem to you and doing it up on the board is because you get to this next step and you say, assume... What do I assume? Now, I've given you a sentence up here, haven't I? But we want some kind of mathematical equation here, something I can prove or disprove, assume, substitute. What could I write that would be mathematically equivalent to what this sentence says? Okay. Well, obviously it's got to have a 4n minus 1 in it, but what could we say about it? Any suggestions? So I'm going to say it must be equal to, and this is why I wrote this as 3 times 1, to try and lead you in that direction. It has to be 3 times some integer, right? Now, you can choose any integer you like. I'm just going to choose p. You'll see why in a second. Now, remember, p can't just be anything, right? So I have to say what kinds of conditions should I put on p? If I want it to be a multiple, right? It has to be a whole number, doesn't it? A multiple, I'm not sure really if that includes negatives, but it wouldn't matter anyway, because our first case is positive, and as you get bigger, it gets more positive. So I'm going to say, p, it's also going to have to be a positive integer of some kind. Okay? So I'm going to assume that that is true. Now what? T-A-P. I want to prove. Well, I should have probably said that. What am I going to prove? This statement in here, right? It'll be the next case along, won't it? What would that look like? Instead of k, I'll have k plus 1, won't I? What should I have on the right-hand side? Now, it's going to be 3 times, well, it can't be 3p, can it? Right? Because it's the next case over. I'd assume the way this works, 4 to the end, it's going to get bigger. It'll be some other number. But that number also better be another positive integer, right? Okay. So how can we go about this? At this point, what do you usually do? You set up your required to prove, okay? So what might you do here? Any suggestions? Okay, you want to probably start with one of the sides, don't you? Okay, it looks like the left-hand side will be a bit easier to work with, and it will provide us something that we can use the assumption in, right? So I'm going to say the left-hand side equals. Okay. Now, by the way, just something I noticed as we were walking around in our outdoor lesson yesterday. Please, don't skip any lines in this, right? I mentioned this to a couple of you, but not to all of you because we were all displaced. But, mathematical induction is the classic example of proving something, but you already know what the result is. Right? So you get no credit for actually doing, you know, the last line there, getting the answer, right? The process is everything, right? The means by which you get there is everything, okay? So every line you skip, it damages the strength of your argument, okay? So therefore, you know, for instance, I could have written here, and I will write, 4 times 4 to the k minus 1, because that's what it is. Right? Index laws, okay? But I would never put that as my first line, even though it's so obviously true. I wouldn't put it as my first line because it ain't the left-hand side, okay? So I'm trying to make sure this argument, it's an argument, I'm trying to convince you, is as watertight as possible. There's no room for you to say, whoa, where did this rubbish come from? And I'd have to explain it, all that kind of thing. It should stand on its own, right? And in an exam, in the HSC, we don't get to mark you based on later on you come and explain, oh, this is what I meant. This, what you write down, that is the sole means by which we can judge you and your understanding. Okay, so make sure it's this kind of quality. Now what? I've used my index laws to simplify it a little bit, right? I know in my head I want to bring in this guy somehow and end here. How can I do it? And by the way, there's many ways to skin a cat. I can see at least 2 primary ways that you can go about doing this. Let me show you one and then I'll show you the other, okay? This is what I'm after, a 4 to the k minus 1, right? Now, is there a 4 to the k minus 1? Is there one of them in this line that I've written? There is, isn't there? It's just not quite as obvious, right? Because I've got this extra 4 hanging around the front, okay? If I just want 4 to the k minus 1, what is the difference between this line and this line? And the answer is, I've got too many of these. I've got extra ones, right? I've got 4 of them here, but I only want 1. So I can't just like get rid of it because it's convenient to me. I have to include it in there. Right? So here are my 3 spares, if you like. Okay? There's the 4 to the k minus 1, which I'm after. I can work with this thing. And this is what I'm left with. Okay? Because there was 1 here, 3 there, that's my 4. Right. Now I can use my assumption. I'm in a position to use what I assumed here. That's 3p. Okay? By assumption. Now can you see where it's going to go? Can you see where it's going to go? I'm trying to end here, 3q. It's a bit weird because I don't know what q is, but it's obvious enough once you take out the factor. Right? That's 3 times this. Okay? Now, you probably, in most cases, could get away at this point just saying that's 3q, okay? But let's be a little more, have a little more finesse. Later on when we do inequalities, it's going to be very, very important. P plus 4k here, how can I justify all of that stuff turning into q, right? On what grounds can I call that q? Q has to be a positive integer, right? How do I know that this thing in here must be a positive integer? How do I know? Did I just pull that out of nowhere? Well, it's made of 2 pieces, isn't it? It's got p, and that's a positive integer, right? And it also has 4 to the k, right? Now, 4 to the k, I know that's a positive integer. How do I know? Because I put some oh, I didn't say it, did I? Fixed. Because k has to follow the same conditions that n does, right? So, because, you know, 4 to the k doesn't have to be a positive integer. If I make k, you know, -1, it's not an integer anymore. But because k has these particular qualities, right? That's why you can say it, okay? Sum of 2 positive integers, also a positive integer. So that's what I'm going to write. Okay, so now it's true for that next value along, n equals k plus 1, the next case. And you can finish the explanation from there. But did you see what we did? You saw the way we did it? Your assumption is as normal, okay? But you want to twist and turn this part here so that you can use the assumption. Right? Now, thank you. I did say you could do it another way. It's not very, very different. But just in case you didn't like what I did here, See how I looked at this point, I said, is there a 4 to the k minus 1? And my answer was, yes, there was. I rewrote it like this, just to make it clear. Okay. The alternative way for how I could do this is, take your assumption here, before you leave it, rewrite it. You can rewrite it like this, right? 4 to the k is equal to 3p plus 1, isn't it? I've just moved the 1 over the other side. Okay. So now you can see the reason why some people like writing it like this and then using that as their assumption. Can anyone tell me? Why would you do it that way rather than the way I've already done it? Because when you get to this point, right, or maybe this point, right, 4 to the k, it's just there. You don't need to do this weird, how do I rearrange it? You just take your 4 to the k, you stick it in, and you will get the same result out the end. It works exactly the same. Can you see why? 3p plus 1 minus 1, it cancels out, right?